Thank you so much for that warm introduction. First, I just want to thank you all for attending. Can everyone hear pretty well? How's it going in the back? All right. Fantastic. So we're going to talk a little bit about the DARPA Memex project, which is but first we have to talk about what the deep web is. So when we look at the internet, and we go to a commercial search engine and we ask the internet a question, who do you think is answering you? It's probably a business, right? That has a business model in mind when they're trying to produce search results that are going to get you to click on things. They're going to sell you advertisements. They want you to be able to look at the most popular things that are coming up in page ranks and things like that. They want you to see what they want you to see, right? Because we are all looking at the internet through a little bit of a filter. And so we can't really judge what the quality of the data is that we're getting back, or how much of the data that we're getting back, how complete the results that we're seeing, what they might look like. So when you actually, a lot of people don't even seem to realize when they're looking at data, I've seen estimates ranging everywhere from 5 to 15% of the visible internet is what it's actually, so 5 to 15% of the internet is what is visible when you're moving through a commercial search engine. I think that probably around 10% is more accurate, but basically there's a ton of data that's available below the surface that may be not necessarily indexed. It could be behind paywalls. It could be on sites that are trying to hide their identity. There could be a lot of things going on there, right? So when we look at the depths of the deep web, we're looking at about, I think that these estimates are a little out of date, but if we're looking at about 19 terabytes of content in the visible web, we're looking at about 7.5 petabytes of unseen data that's available below the surface. And there's a lot of data there that can be used in order to gain insight into various activities. Inside the deep web, there's a subset of pages that we're going to call the dark web. And these are pages that are intentionally hidden, where people are trying to purposely hide their identities, and they're trying to do business in such a way that they completely obfuscate who is involved, both on the buying and selling side, or who on the browsing and the serving side. And the goal of the Memex project is actually to look at these regions that are not necessarily usually looked at. So many of you probably heard about Silk Road. This is something that was happening in the dark web, where basically somebody set up an illegal drug trafficking site that was available where people could buy drugs. There were also several charges of murder for hire that were not carried out, but these were the allegations that were against the creator of Silk Road. There was the Silk Road version 1, Silk Road version 2. I've even heard of Silk Road version 3. But the government has gone after sites like this in order to shut them down. So we're going to talk about the DARPA Memex project. So what we're doing here, we realize that for government use cases, the web search use case, the normal one-size-fits-all search, is not really going to work for most government agencies. They need to be able to look at deeper levels of the web. They need to be able to search and index into parts of the web that people are not necessarily looking at right now. DARPA launched this program in September of 2014. There are about 17 teams that are working on this. Continuum Analytics, I am the co-principal investigator for the Continuum Analytics team. And we are actually on 2 of those teams. So we work with both NASA JPL kitware on one side, and then on the second team that we're in the NYU, Cornell, and Continuum team. So what we're doing here, we're trying to develop software that advances online search capabilities. We want to be able to point crawlers in places of the internet that are not traditionally indexed by commercial-based search engines. We want to produce ways to look at that data, understand what's in that data, present that data, and search that data to make it available to those who might be able to use it. So we're creating this new domain-specific indexing and search paradigm where we want to be able to discover new content, we're looking to improve information extraction, information retrieval techniques. And then we also want to encourage user collaboration. One thing I'm going to harp on quite a bit during this is that this is an open source project, which is pretty progressive for DARPA. They're funding open source projects that are working on these problems. So we want to, basically the idea is that we want to increase our current search capabilities to look at the deep web, the dark web, where we have the identities are hidden. But then we also want to be able to look at non-traditional content. So if we're looking at pictures or multimedia, rich text formats, so even Excel spreadsheets, PowerPoints, things like that that might end up on the web, we want to be able to index all of these and search them and find information from them. So the idea here, we're pulling together basically the traditional web scraping technologies. We're interacting with high performance computing. We need to be able to use machine learning in order to be able to focus our searches and understand what relevant content looks like in order to help law enforcement agencies bring down people who are doing illegal things on the internet. So some of the search domains that we're working on, we actually, for the last year and a half, there's been quite a bit of effort on the human labor trafficking side of things. This one includes sex workers. So crawling for information on Backpage, identifying victims who may be involved in organizations that are trafficking them across different areas. I think maybe some of you may have seen some of the press for the Super Bowl this last year. There were a record number of sex workers trafficked in for the Super Bowl this year. And actually the internet makes this possible because people are able to actually, they can estimate the demand. They can set things up ahead of time. People are able to respond to classified ads. They're able to move things pretty seamlessly and also move funds seamlessly across the internet. One thing to also mention, the human labor trafficking domain that's very interesting is there are a lot of search capabilities and images has come out of this domain where we're actually able to tag different pictures of different victims of this exploitation. So we can catalog pictures, but we can also search for them across different sites. So we can see the movements as people are being moved from location to location. We're able to find them. We're able to document information about them. We're even able to pull things out of the pictures where we're able to find locations. We can document whether or not there are any props or whether or not a room has been used in other pictures. We can also catalog things like identifying markers like tattoos and things like that, which is actually pretty common practice in when people are selling humans. They might tattoo them with their particular organization's sign or something like that, which can help us identify who is actually moving the people. This is also, we're partnered with the ATF looking at weapons trades. Material research science, where we're looking for different materials that are being moved in different areas, particularly anything that may have any kind of military application. Financial fraud. So we're partnered with the SEC, pulling in lots of financial information, looking at front running or pump and dump for people who are moving or basically inflating the price of stocks, manipulating the market, and then dumping the stock and basically taking people for a lot of money. It's a huge problem. It's a huge manipulation of the market in the first place, but it's also an extremely important vector for money laundering. So they want to be able to identify this and stop it. Counterfeit electronics. This one is not so much looking for people who might be just creating electronics and selling them, with the wrong name or something like that, may have like the Apple version of a particular phone or something like that. But they are looking for electronics that are entering the US supply chain that may interfere with military operations. So in particular, looking for espionage backdoors and also counterfeit electronics that have sabotage triggers incorporated into them, which may put other people's lives in danger. Not to mention, it's also just a huge amount of waste when the US military is wasting money on counterfeit electronics that they can't use actually out in the field. Patent trolling, so looking for companies that may not necessarily have a lot of revenue, but have a ton of lawsuits filed against different people. And also, intellectual property infringement, things like that. And possibly the most heartbreaking domain that we work on in child exploitation. So much like working with the human trafficking and labor trafficking, documenting and finding information about children that may be exploited and missing. And there are other search domains. I'll actually mention a couple of them while we go here, but these are just a sample of some of the different domains where these different technologies can be applied. So, as I mentioned before, these are open source tools. So we're looking here, this is a Forbes article that came out where it actually has a screenshot up here of DIG, which is one of the other teams that we work with, is from the USC, where they are finding information. You can tell that this is for the human trafficking domain, where they're cataloging pictures of different workers that may be advertising on Backpage or on other sites similar to that. And then also just to mention, all of these are cataloged on the DARPA Open Catalog. So all of the open source projects that are out there are available on this open catalog. And if you actually search under Memex, you can find the ones that are particular to this domain. And so there's a lot of good information there. A lot of different organizations are involved here. It takes a huge amount of effort on everyone's part in order to pull all of these things together. So I just want to talk a little bit about the overview of the ecosystem for a large-scale data analytics platform. So we're talking about basically indexing into huge amounts of data on the internet. We're pointing crawlers across and pulling data from all the nether regions of the internet, pulling it into indexes and making it searchable. This is a huge challenge. So when we look at what it's going to take in order to build a platform that can do this, we have to integrate several different disciplines, right? So we have distributed systems, we have the BI database, so business insight database, more traditional relational databases, and then scientific computing and data mining, stats, and machine learning. We have to pull from all of these different things. So on the database side, we're working with MongoDB, SQLite, SQL Alchemy, Postgres, MySQL. These are things that people have probably all seen before. These are all open source and available for people to use. Oops, wrong way. On the data mining side, and on the machine learning side, we're using R, KNIME, scikit-learn, Pandas, Weka. We have quite a few different pieces that are coming together in this platform. So we're using a whole lot of different technology, throwing it at this problem. Scientific computing, we're looking at using Numba, Blaze, which is another a Continuum project, Numba, which is also from Continuum, HDF, and PyTables. And then in distributed systems, we're looking at backends that are going to sit on top of Hadoop and Spark, Hive, and Impala. So, and then there's some crossover between these different pieces where we're able to interact between the different disciplines. So Mahout, obviously, people are probably familiar with that. We're using that for machine learning in order to train models that are used for directed crawling. And then also our Hadoop is available. So our analytics pipeline is actually kind of simple. It's very similar to what you would expect when looking at a commercial search engine. So we send out web crawlers and scrapers that go out and collect content. We want to be able to extract entities, so we're pulling features out of these pages. So when we're looking at a semi-structured text on a web page, we can pull out buying and selling information, phone numbers, addresses, payment information, images, anything that might be identifiable. But we are trying to stay above the network layer, so we're not looking at IP addresses and things like that. We're really just looking at content on this side. Because we found that, especially for areas where people are obfuscating their identity, the IP address, server information, things like that, those are ephemeral. They're going to change. They're going to go away very, very quickly, and they're not good identifiers for finding people out who are involved in these activities. Then we have indexers involved here, where we take all the information and put it into an index. And then on top of that, we want to add some visual analytics so we can tell what sort of information that we've actually collected. So our team at Continuum Analytics is mostly responsible for Memex Explorer, which is a pluggable framework for crawling and data discovery. It's built on Django, so it is a Django web application that you can interact with. We have Elasticsearch Index on the backside, so we're putting everything into Elasticsearch for searchability. We have bouquet visualizations for looking at crawling stats, and also for looking at information about what you've collected in your data. And then we're also using Kibana dashboards. I can't say enough good things about these dashboards. I don't know if you've ever looked at them. You can just point them at an Elasticsearch index and visualize data super fast. It's amazing. And I'll do a demonstration showing that later. Then the different crawlers that we have integrated so far into Memex Explorer are the Apache Nutch crawler. And then from NYU, we have the Ache crawler, which is, both of these have directed crawling capabilities, so we can actually upload a classifier that will direct crawling into different areas, or also classify outlinks, whether or not we want to follow outlinks and follow that information deeper into the web. And then on top of that, we also have the NYU domain discovery tool. And that allows us to basically take a really simple search, but then be able to expand it and be able to train classifiers based on information that we're actually manually marking relevant or irrelevant as we're looking at the information that comes up. So just want to mention, our partners over at NASA, Jet Propulsion Laboratory, are Apache developers. So they're all working on Nutch and Tika. The Tika project, I think, is particularly interesting because it has the ability to do first-pass extractions on the information that we're grabbing from the web. So we can pull, and this includes rich content, actually. So it can take image information, give you information about the camera that took the photo, right? You can find information about, do automatic translation. You can do on different pages. You can find author information on docs or PowerPoints and things like that. It can pull out a lot of information from different page sources, including, I mentioned, docs, PowerPoints, PDFs, all sorts of different document types. So we use that as a first pass to pull information and content out of the information we're collecting off the web. And this gives us, it kind of puts everything into a format it's standard, right? We know what fields are going to come out of Tika. We have the idea what sort of text we're expecting, and that's what we use as our first pass. There are other extractors that it may go through past this pipeline, right? So I mentioned Dig earlier from USC. That's another extractor that we put pages through so that we can pull out author information, year publication, things like that. And then I also wanted to mention on the NYU side, these are open source projects, as I mentioned before. So Ache and the domain discovery tool are both available through GitHub. So this is a screenshot of Memex Explorer, but I always think it's a little bit more fun and more adventurous to do a live demo. Right, so here's Memex Explorer. The idea here is that we have different projects. These would correspond to the different domains that you're looking at. So if you have a law enforcement agent that wants to look at information, wants to direct a crawl, wants to find information on a different domain, the idea is that they would start a project here, and this would be kind of the beginning of their exploration. It's also the beginning of their investigation into a particular group. And the idea is that they can hold all the information about this particular exploration to one location that they can then come back to. I'm going to start over here in patent trolls, actually, and I'm going to start with the domain discovery tool. It's going to take a minute for it to load up here. But what we're looking at here, this is already pre-populated. You don't necessarily have to have pages that are pre-populated. I just did this for demonstration purposes, but you can also basically start with a web search here, put in the key terms that you might be looking for. So in the case of like maybe, so what are we looking at here? Patent trolling, you may look for key terms that have to do with patents, guaranteed, intellectual property, things like that, where you're able to put key terms in here, get back results, and then we're looking at the pages. This is just a distance-based metric of how similar the pages may be to one another. But then we can come through and actually select portions of these pages. You can't see that very well, but these pages are coming down here where you're able to see a preview of what is on the page, right? And then the idea is that from this preview, you would be able to tag it as being irrelevant or relevant, or if it's just neutral. It may have relevant information, it may not be that important, but it may also have some really nice terms in it that you want to be able to use. And so once we have, okay, I'm going to come back out of there. Once we've, and you can see here, once we've labeled our different pages as being relevant or irrelevant, we can look at the key terms that come up here. And what's nice here is also as I scroll over these, you can see that the text, so you get a little bit of context of where this term came from the web page. You can see information that may be relevant around it to determine whether or not this is actually a key term that you're interested in. And then ultimately, as you've now created labels for all of your data, just hit this model button here, right? And it's going to train a classifier for you. So in this case, we're actually defaulting to a naive-based classifier. We're just using a bag of words model. Very, very simple, just regular keywords terms. And then once we have this model file put out, we'd be able to come back to Memex Explorer and add a crawl. We give the crawl a name. Down here, we specify which crawl model we want to use. So we're going to direct our crawl based on the relevant or irrelevant tags that we've added to the pages already, and then submit it. It'll go out, crawl the web for as long as you want it to, pull information back in, index it into Elasticsearch, and then you'd be able to visualize it through the dashboards. One of the nice things that comes out here also, I think I actually have it set up for this one, but over here in autonomy, here's a crawl that was already done, I guess, last week. You can see here, these are bouquet plots where we're looking to see crawl statistics. We want to see how well our crawl did. So we can see out of all the pages that it visited, what is our harvest rate? What are the pages that we found interesting? What are the ones that were classified as being important to us and to our domain? Pull it back in, and that's the information that ends up in your index, right? When you look at this particular classifier, by the way, you may notice that, how many are relevant, how many are irrelevant, things like that. This doesn't look like a particularly compelling model. If you may look at like how much was crawled and then how many things that we found to be relevant, that's pretty high. We're looking at about a 90% harvest rate. We may end up retraining or changing our labels or something like that in order to bring that down. Because we really do want to just grab the relevant information that is going to most help law enforcement agencies in order to build cases against people who are involved in these activities. So going back to my slides, you can see that screenshot of Memex Explorer there. I just want to mention some of the tools that are used here. So this is built on the Anaconda platform, so it's a Continuum Analytics product. It's free, it's available for download. It's kind of a kitchen sink included Python distribution. But it also has Conda involved, incorporated into it, which is our package manager. All of the packages that are involved in Memex Explorer are available through Conda. So you can Conda install Nuts, you can Conda install Tika, you can Conda install any of these different tools, including Domain Discovery Tool even. You can just Conda install them. I also want to mention Blaze. This is something that is really important because working across 17 different teams, as you can imagine, people are pulling data from all over the internet, putting it into different backends. They're putting it, all sorts of different formats and things like that. We try to standardize as much as possible, but especially when somebody's, one person is using HBase, another person is using HDFS, another person is using Elasticsearch, we do like to have a consistent front end to be able to manipulate data, and Blaze provides that for us, where we're able to actually do in-database operations, do compute, pull things out, move things into data structures easily, and reduce our amount of code, actually. And then I just wanted to mention that Blaze has this computational backend, as I mentioned before, so we can do in-database operations. We have data storage and abstract expressions so that we're able to succinctly describe what sort of manipulations we want to do on the data. I also want to mention Bokeh, which is interactive visualizations. I'll do some more demonstrations in a minute with Bokeh, but definitely wanted to mention it because it has made it very easy to be able to interact quickly with our data and show results to people, and especially if there are particular parts of the data that they're interested in, they can kind of hone in on those parts without having to worry too much about revealing, I don't know, sensitive information, classified information. This is an unclassified project, right? Where we're looking at data. We don't necessarily know exactly how they do their investigations. We're just collecting data and making it available, providing search tools for people. I also want to mention scikit-learn, fantastic product, right? And so being able to train the classifiers. I did mention Weka before and Mahout, but we also use scikit-learn in order to train classifiers. We get, depending on the type of model that you're using, you may find that some packages work better than others, or you may get better performance from different projects. So when we're looking at data analysis, we've now collected all of this information, right? We've indexed it, we have it somewhere. You have no idea what's in it, right? Nobody's going to go through and look at every single one of these pages that was crawled. Nobody wants to look at each one of those pages individually and determine what sort of information is in them. But we do want to be able to look and see what we have, right? So a really good way for us to do this is to provide topic modeling on top of this. So when we look at text on web pages, we can do, this is an unsupervised procedure where it's basically clustering based on words, right? So we're looking at, there are different ways to do it without getting into the specifics of how topic modeling works. The idea is that we're clustering information from documents into different topics that may be relevant to that particular domain. And when you do that, you get back, there are different ways to look at this data. I'm actually going to break out of this and go to another demonstration. This is for the material sciences side. I have the screenshots as a backup just in case my internet connection flaked out on me, you know. But the idea here, this is from material research science. We basically, took about 70,000 documents and indexed them, which is not a great, it's not a huge amount of data. It fits in memory. We're able to, do manipulations on it pretty quickly. But for a proof of concept, this is a good way to explain what's going on. But we can see what kind of terms are showing up in each one of the topics. So the x-axis represents the different topics that were found in the data, and then the y-axis represents all of the key terms that are associated with that particular topic. You can see here that there are some that are shared across different clusters. You can kind of see how that works, and it gives people an idea of what sort of information is in the data that's been collected. The one thing that I do want to mention, that's a challenge in using topic modeling in order to look at data, is that there's not really a good way to map what these topics are in relation to how you might describe them to somebody. It's not like you can say like, oh, these are all related to, nuclear technologies, or these are all related to some other technology or something like that. There are different ways that we've looked at in order to seed them to try and make that a little bit better, but we've also found that generally we lose a lot of performance in the clustering algorithms when we try to seed them and try to manipulate that too much. So it's still an open problem, but this still gives people a general idea of what's in there. Related to this, also in the topic modeling side, we're using LDA under the hood in order to do our topic modeling. And so when we have this LDA visualization package, this is actually from an R package called LDA Viz. And this is a really cool visualization where we can look at the different topics involved, what key terms are available, and then how it relates to the total number of occurrences of that key term across the entire corpus. So you can kind of see what the co-occurrence or what sort of percentage of your key terms are wound up in that particular topic. And then, just explore each one of these as you move through. And then I also just want to mention the word cloud app. I think that this one is a little bit, I was a little surprised actually that people find this to be so helpful, but some people really like seeing key terms in pretty pictures, I guess. But as you can see here, I mean, is this particularly helpful, right? Films definitely kind of dominates the picture here, but we can put stop words in here. And then we can also filter out kind of our lowest percentage and our highest percentage of words to kind of get a better idea of what's in here. Let's say that we're going to go ahead and put this in 2 intervals, so we want to look ahead and see how things have changed over time, and then update it. So here you can kind of see how things have changed over time. You might find some keyword terms that would be useful to you, that might be interested, that point to papers or point to information that you would find interesting in this particular domain. When we come back to these other tools that are over here, I was mostly talking about what my team has been working on, but one thing I did also want to mention, our partners over at JPL put together this facet space demonstration. This is on the same collection of documents. And so here, taking those keyword terms that you found from the unsupervised processes that we put all the papers through, you'd be able to add these search terms here and then find facets of information and then actually get back to the papers involved that actually describe those particular pieces of information. And then, as I mentioned before, I also just wanted to mention Kibana dashboards. As I said, this is freely available. I'm just amazed how quickly you can build visualizations here, and they're interactive, right? So as you move through here, you can actually look at different trending information. So we're looking here by country, who's been publishing in material science over time. And you can see different jumps in different countries and things like that. Obviously, it's mostly dominated by the United States here. And then down here, also tagging different papers with keywords. So in this case, if there were particular materials that people were interested in looking at, you'd be able to look and see which countries are involved in research for those particular materials that are tagged in the different documents. I think it's a really great way. It's amazing, like I said before, putting this dashboard together basically took about 15 minutes. You can put all of this together, point it to your Elasticsearch index. It walks through how to do visualizations, and then you don't have to write any D3, you don't have to write any code. It just automatically puts it together, and you can save it out into a dashboard. So coming back here. Right, so I also wanted to mention some of the technologies that we're using. As I mentioned before, on the back end, we're using Elasticsearch, and Kibana is also available through elastic.co if you're ever interested in playing around with that. I just wanted to thank you for your attention, and if anybody has any questions, definitely let me know. Over here? So the question is, who has access to this technology? And since it's open source, everyone, right? So everyone can use it. I think the data is proprietary, right? Because that's very sensitive. I mentioned, these demos that I showed you that's not sensitive material. There's not anything all that damaging in there, right? But you definitely, but the technology is available to everyone. Back here?
It seems that you are trying to regenerate or develop index of the hidden web. So
yes.
What distinguishes you from somebody doing this outside? Like, do you have any privileged access, or do you have ways of getting around, let's say, password protected sites, something like that? Like, this project can be done by anybody, and the guys who are doing this will be trying to protect them from, let's say, web crawl and stuff like that. And the other question was, like, if you guys are doing this, we don't know for sure, but we heard about NSA or other folks from the government doing this. So how does that differ from what you guys are doing? You guys are only adding value, or is it more information?
Well, I think, okay, well, I'll first start with your first question, right? So talking about if we have access to special tools that allow us to index into deeper parts of the web or different parts of the web than other people. And that's the information retrieval teams have developed technologies that do allow them to move into spaces that other teams can't necessarily. They have to develop their own technology in order to do it, but we do have crawling teams that work specifically in like Tor sites, things like that, and moving into parts of the web that are not necessarily indexed. And then how does this program differ from some of the other programs out there like NSA and things like that? I can't really speak to that so much, I think, because I am not the program manager on that. But I did want to mention, I think that one thing that's definitely very different here is just the fact that these are open source tools, right? So this is democratizing search and making it available to anyone who might be interested in this sort of technology, and making the technology available to anyone who might be interested. Right here.
You mentioned we crawl things like payments data. So how do you, the web doesn't have payment data on it, right? So how do you crawl that?
Some sites do. I'll just put it that way.
It's exposed to the web?
Yeah, so especially at some storefronts and things like that, especially when you're looking at goods that may be sold in particular domains, do have information about different methods of payment that are available, or different links to places that you would have to go in order to make a payment. So that's kind of information that we can index. Anyone else? Over here? I'm sorry, 1 second. Over here.
I guess I have 2 questions. I've read recently that people are talking about using the blockchain to store contract information and non-financial content. Is there any research that you know about in terms of trying to, I guess, essentially interpret what's in blockchains?
So the question here is, are we looking at interpreting information that's in blockchains? I don't know about that, I'm afraid. Over here?
Yeah, so if you're crawling these illegal websites on the dark web, does the government, how can they distinguish someone who's trying to help from someone who's like looking for a service?
That's for the domain experts. So the question is, how do we determine the difference between people who are legitimately trying to do business and those who may be bad actors out on the web? And this is where the domain experts come into play. We actually, search in kind of a, collect as much data as possible way, right? But the domain experts, they're the ones who can actually cull the data and tell us, whether or not this is relevant or irrelevant. The idea is to give them tools in order to be able to work through that flow easily. Because right now, a lot of investigators are really, they're sitting down at their browser, clicking through sites manually, trying to keep track of information in an Excel spreadsheet or something like that. And we just want to make sure that they have better tools in order to find information they're looking for. Back here?
So you mentioned work on how to learn. I was surprised that you didn't mention Spark ML built for large data sets, Spark scales and all that kind of bunch of stuff. Is there a reason for that, or some study that decided not to use that? Or,
I'm sorry, what was the question one more time?
So you mentioned WCAT, Mahout, and scikit-learn, and I was surprised to not hear you mention Spark ML lib. Even how Spark scales and
Oh, sure. We actually do use Spark, by the way, in our tools. I was talking about particularly what my team was doing. People are definitely using Spark ML. There are other teams that are definitely using it. For the topic modeling, actually, recently, one of our developers added Spark support for that, because obviously we're working with these huge sparse data sets and sparse matrices of information, and Spark works really, really well as a backend for that. It's probably something that we should look into in the future, but up to this point, those packages have been sufficient for our needs. Anyone else? All right, thanks. One more.
So are the features that you collect, like how, and the feature extraction techniques, are they also open source or?
Yes, extractors are on that webpage.
So all the features that you're using are not?
I don't think that they add the fields that they're looking at and how they actually extract them. That would obviously be sensitive, right? To let people know what sort of information is being collected, but the framework is out there. Yeah. All right, thanks again for your attention, and also just wanted to give a shout out to my team. They're fantastic. They do amazing work and work really hard on this project, and it's a pleasure to work with them. Thank you.
Thank you, Katrina.